Assalamualaikum and good afternoon, everyone. Thank you for tuning in to the second part of Future Ready Engagement Series. I'm Rihanna from Yayasan Mendaki Future Ready Department. Mendaki and a group of engineers have come together for this session for you. The aim of this series is to create better understanding of the industry and in support of home-based learning for our students, youth, and working professionals in the community. Before we invite the speakers, there are some rules for the webinar session. As a participant, you will have the Q&A, chat, and poll buttons at the bottom of the webinar screen. If you have any questions for the panelists, do type in your questions in the Q&A portion. We do not encourage you to type your questions in the chat function. We have gathered some of your questions asked through the registration form and consolidated it in this poll. We will now launch the poll. Kindly participate in this poll as the top few questions will be answered during the Q&A segment at the end. Without further ado, let's invite Mr. Sharil Taha, moderator for today's session. Mr. Sharil, please.
Hi, everybody. Assalamualaikum and good afternoon, everybody. So thank you for joining us in this session. This is the second, as Liana said earlier, this is the second of the Engineering and Future Technologies webinar series. Last week, we had our first session. We kicked off our first session with the theme Engineering as a Career. And we had a fantastic sharing session by our three speakers, Mr. Lokman, Ms. Norashikin, and Dr. Airil Seet, sharing with us on their engineering journey. So this week, in the second week, I'm quite excited to launch the Tech Talks. Yeah, let me just share with you my slides. All right. So this week we'll be focusing on Tech Talks, and we'll cover a bit on how a gas turbine engine works by Dr. Airil Seet. Mr. Amir Zakaria will give us an introduction to robotics, and Dr. Ahmad Anwar would talk us through introduction for additive manufacturing. So the agenda for today, the first 45 minutes, we'll let the speaker share with us their experience in this field, and subsequently, we'll have a Q&A session for 15 minutes. Yeah. So as Liana said earlier, if there's any questions, type it into the chat box and vote for it, and then we'll try to address it. Yep. Okay. So before we begin, let me introduce the speakers. Maybe the speakers, you want to turn your video on and then wave to the guys as I mention your name. So Dr. Airil Seet. So Dr. Airil Seet is a functional and vibration lead engineer. He is also the whole engine design team lead for Rolls-Royce Singapore. He holds a PhD in aerospace engineering, specializing in unsteady aerodynamics, and holds a second upper BEng in mechanical and aerospace engineering from NTU. So Dr. Airil Seet holds 2 patents with Rolls-Royce for his invention during his time with repair development, and he is also the first Singaporean engineer to be awarded the Sir Henry Royce Award for Engineering and Technology. So Dr. Airil Seet, if you want to wave to the guys, the participants, sorry. Thank you, Doctor. Okay, next up, providing the introduction to robotics, we have Mr. Amir Zakaria, who is the robotics trainer at Robotics Automation Center of Excellence, RACE. So Mr. Amir Zakaria has a bachelor's in electrical and aerospace engineering from Queensland University of Technology. He is a robotics trainer at RACE. He directs the curriculum for robotics training. Not only is he experienced in robotics, he has also delved into the field of UAV, unmanned vehicle development, and he also does industrial 3D printing. So Mr. Amir Zakaria, maybe we can wave to the participants. All right, fantastic. And introducing additive manufacturing for this session, we have Dr. Ahmad Anwar, who's currently a research engineer at Republic Polytechnic. So Dr. Ahmad holds a first-class honors degree in aerospace engineering from NTU. He was also conferred the Doctors of Philosophy in the field of additive manufacturing from NTU also. So currently he's a research engineer working on urban farming solutions with IoT application. So Dr. Ahmad, maybe you can wave to the participants. And for myself, Sharil Taha, I'm the moderator for today. I'm still an engineer at heart. I'm driven by the passion to innovate and I love working on change projects. And my current passion right now is pursuing the next Industry 4.0 change program. I used to work in oil and gas, automotive, telco, and now I'm in the aerospace industry. In my last role, I was building facilities and factories in UK, Canada, Singapore, and Germany. So without much further ado, let's kick off this session. Let's let Dr. Airil Seet kick off this session with introduction to gas turbine engines. Dr. Airil.
All right. Assalamualaikum. Good afternoon, everybody. So just give me a minute. I'll share my content.
All right, maybe you can give Airil a few moments as he shares his content.
Yeah. Can you see the screen? All right.
Not yet for me.
Okay, hold on. All right. So I don't know what you can see. So can you see the slides?
Yeah, now it's appearing.
Okay. So can you see the slideshow?
Yes, we can.
Okay. Hi, Assalamualaikum. Good afternoon. I'm Airil. So today I'm going to present to you how a gas turbine engine works, right? Right. So before I touch on that, let me explain to you how an aeroplane flies and what are the aerodynamic forces in action here, right? So firstly, you need to have lift, right, to enable the aeroplane to take off and fly. And this lift force needs to overcome the weight of the aircraft and the engine due to gravity, right? Then you need to have the forward force called thrust in order to enable the aeroplane to fly forward. And this thrust needs to overcome drag force that acts in the opposite direction. All right, so when you go on holiday, you see very big engines mounted on the aeroplane wings. And the main purpose of this gas turbine engine is actually to produce thrust, that forward force to keep the aeroplane flying forward, right? So I'm guessing many of you know who this guy is, all right? So this is Sir Isaac Newton. He discovered gravity and laws of motion, among many other things. All right, so thrust, the forward force, all right? So it's based on second law of motion, which is force equals to mass times acceleration. So I'm guessing many of you have seen this equation before in your secondary school days. So to me, how a gas turbine engine works is to make the air do the work, right? So mass, what is mass? So mass is the mass of air that is being sucked into the engine. And then you want to accelerate the flow of air going into the engine and going out at the back of the exhaust of the engine. So once you have the mass of air and the acceleration, you actually produce force, which is your forward force called thrust. Right, so to illustrate this concept better, so imagine you blow a balloon, right? And then you let the balloon go. So what happens is that you have fast moving air escaping at the back of the balloon in this direction. And then what happens to the balloon? The balloons propel forward, and that is your forward force called thrust. So this is also another example of Newton's third law of motion in action. So for every action, which is the acceleration of flow at the back, there is an equal and opposite reaction, which is your thrust that propels the balloon forward. So this is another concept to demonstrate that makes the air do the work. Right? So how a gas turbine engine actually produces this forward force called thrust is by 4 basic operations that the engine needs to carry out. So firstly, you have your suck, which is sucking all the air into the engine, and then you squeeze the air, and then you combust the air. So you make a loud explosion in the combustion chamber, and then you blow the air through the turbine and the exhaust of the engine. So suck, squeeze, bang, and blow. So I'll show you a short video to illustrate these 4 basic operations. Right? All right, so I'm hoping that you enjoyed that video. All right, so for the first operation, you have your sucking operation. So you have those big fan blades, so-called the low pressure fan assembly, to suck in all the air into the engine. So most of the air for a turbofan engine bypasses the core, right? And some of the air goes into the core, all right? So how much air does a turbofan actually suck? So for a Trent 900 engine, it sucks about 1,000 kilograms of air per second, and that's equivalent to a size of a squash court, all right? And one more thing is that if you notice a Rolls-Royce engine, there's a rubber tip at the nose, and that's invented by a Rolls-Royce intern. And the purpose of this rubber tip is actually quite ingenious, right? So typically during winter times, and sometimes you have aeroplanes sitting out in the open for a very long period of time, and then you have ice depositing at the front of the engine. So this rubber tip will actually vibrate when the engine is in operation to shake off and break all the ice that is deposited in the front of the engine, right? So now we look at how the fan blades have evolved through the years, all right? So since the 1980s, with the first generation of fan blade, it's have adopted a more of a honeycomb construction to minimize weight while maintaining structural integrity and strength. And then you moved on to the second generation of blades in the mid 1990s, where you have your titanium hollow construction that consists of 3 layers of titanium sheet, and then you blow it up to create that hollow structure. And another fun fact is that our Rolls-Royce Seletar plant in Singapore actually have one of the largest fan blade manufacturing facility in the world, right? So in more recent times, we are looking at a titanium composite fan blade that consists of a titanium leading edge here, and the main body is a carbon fiber reinforced composite. So our composite titanium fan blade alone saves a huge amount of weight, about 1,500 pounds per aircraft, and that's equivalent to 7 or 8 additional passengers traveling. So after you suck in the air into the core, you want to squeeze the air, right? So in the compressor, it consists of a number of stages of stator vanes. As you can see here, it's stationary, it doesn't move. And then also it consists of compressor blades that are rotating. So as air moves through these compressor stages, it actually gets squeezed even more. So air pressure actually increases through these stages. So for a Trent 1000 engine, it has an operating pressure ratio of 50:1. So meaning to say that if you were to start at the inlet with a pressure of 1 kilopascal, at the end of the compressor stages, it's going to squeeze, and the outlet pressure is going to be 50 kilopascal. So it increased 50 times that amount it starts with, right? So once you have that compressed air, you channel it through the combustion chamber, then you burn it. So you ignite it, and then you have fuel spray nozzles to spray fuel and mix it together with the compressed air and ignite it, causing combustion, right? So the temperatures in the combustion chamber can go up to really high, about 1,600 degrees Celsius, which is nearly the half of the temperature of the surface of the sun, right? Imagine that. So once you have that hot expanding air, right, it's then being channeled into the turbine stages, and then rotating the turbine at a very fast speed. And the turbine will then turn the compressor stages and the big fan in front of your engine, right? So the temperatures here are ridiculously hot. So it's a very harsh environment that the components are exposed to, right? So the components around this area are a little bit special. So take, for example, the HPT turbine blade, as you can see here. It has a couple of unique features about them. So firstly, I think you can see that it has a series of cooling holes on the airfoil surface. So you channel the cooling air from the compressor up to these cooling holes to create that envelope of cooling air surrounding the turbine blades. So to make sure that your turbine blade doesn't melt, doesn't deteriorate that much, right? So, and it also has a special coating called the thermal barrier coating to help to withstand this kind of harsh environment and high temperatures. So another fun fact is that at takeoff, each of these turbine blades actually produce over 800 horsepower, and that is equivalent to an F1 car, right? So a lot of work there. So let me explain to you two most common gas turbine engines. So you have your civil turbofan engine that you normally see mounted on your Singapore Airlines plane, and then you have your military turbojet engine that you normally see at the back of a fighter plane, like an F-16 plane, for example. So these two engines are examples of gas turbine engines, but there is one fundamental difference about them, is that they generate thrust differently, right? So in order for me to explain this difference, I need to introduce you to a term called the bypass ratio, all right? So what is this bypass ratio? So take, for example, a civil turbofan engine. So you have your big fan sucking in all the air into the engine. So this air is being channeled into two areas. So one bypasses the core of the engine. So we call it the cold bypass air. And then some of the air will go into the core of the engine. So the bypass ratio here is actually the mass of the cold bypass air over the air that is sucked into the core, right? So for a civil turbofan engine, it actually has a very high bypass ratio. And take, for example, a Trent 1000, it has a bypass ratio of about 10. So what this means is that most of the thrust that is being generated by a turbofan engine is actually produced by the cold bypass air here, right? So when you look at a military turbojet engine, it's a bit different, right? So as you can see, most of the air that is being sucked into the engine is being channeled directly into the core of the engine. So most of the thrust is being produced by the hot exhaust air coming out from the back, right? So typically a turbojet engine has a very low bypass ratio, about 0.4, right? And one thing special about a turbojet engine is that you can have afterburners at the end, at the exhaust, to further ignite this hot expanding air to further give that acceleration that the fighter pilot need, right? All right, so I've come to the end of my short presentation, and I'm really hoping that I can ignite some of the passion in engineering. And personally, I'm very excited to see what the future brings, especially with emerging technology, with newer design of engines such as your turbofan here, and your hybrid electric engines here. And then you have your innovative, radical airplane designs that I'm looking forward to see in the future. And I've been in industry for about 7 years now, and I'm still learning every single day. There's so much things to learn. And with that, I want to say a big thank you to Madaki and Sharil as well. And before I leave, I would like to share with you a quote by Thomas Edison, which states that many of life failures are people who do not realize how close they were to success when they give up. So with that, thank you so much. And I'm hoping to see some of you becoming engineers one day, inshallah. Right.
Okay, thank you, Dr. Airil. Thank you for that very interesting session on how a gas turbine engine works. So I hope, as he mentioned, and I guess, pardon the pun, he ignites your passion for aerospace engineering and gas turbine engine. So a lot of good things there, from refreshing our memory on Newton's second law of motion. Talked a bit about the bypass ratio and all the interesting fun facts of a jet, or rather a gas turbine engine, even operating at the core temperatures of 1,500 degrees Celsius. Fantastic. So thanks a lot, Dr. Airil. Next up, we have Amir Zakaria. Amir Zakaria, I've known Amir since he was a young boy, maybe about 4 or 5 years old, and I'm really glad to see him here today. So as mentioned, Amir is the robotics trainer at RACE, which is a Robotic Automation Center of Excellence. Not only does he deal in robotics, he works with a lot of the latest technologies, from UAV to even industrial 3D printing. So Amir will walk us through introduction to robotics. Amir, take it away, please.
Thank you, Sharif, for the introduction. Very kind words. Okay. Let's see. Okay. You guys got the full screen?
Yep, very good.
Okay. All right. Thank you guys for making some time to come down and join our talk. So today I'll be covering a bit about the intro of robotics. Sharil has given a quick introduction to a bit about myself. But I just want to say that I come from aerospace background. Not that I worked there, but that was my path trajectory when I started studying in diploma. And then as I went on, my career path changed and on to robotics. All right. So how did robots come about? So back in the day, I didn't live it back then, but back in the day, people need some of the machines that can perform some of the tasks that can help increase their productivity in labor. So they created some machines, like starting from windmills and some of the tools that can help them better. For example, farming, right? And then in the early 1900s, they start to come up with machine with the first and second industrial revolution. And then in the late 1900s, in the 1970s, that's when ABB first made their robotic arm, their first industrial robotic arm that can carry up to 1 ton, 2 ton. They can help them increase their productivity in their manufacturing processes. So that's the very first start of robotics. So what are the types of robots? So I'm going to cover a little bit about industrial robots for now, because that's what we cover a lot in work. So industrial robots can be broken down into 3 parts: manipulators, mobile robots, and automated material handling robots. So the first part about manipulators. Manipulators can be classified as your robot arms. Reason being because they really look like your arms. All right. So when you talk about industrial robots, manipulators are one of the most common ones, and you have different brands for now. And started from ABB, and then now you have KUKA, you have even Universal Robots for now. And some of the parts that they make up of are your joints. So the joints are typically made up of your servo motors and harmonic drives. These are special types of motors that can help increase your accuracy in movement. And then at the end of it is your end effector. They are your grippers or your fingers, right? So this itself is another type of field of study. End effectors, there's many different types. Brands like OnRobot, they got suction grippers, they got claw grippers. So that itself is another field of innovation. Then last but not least, you have your motion controller. Of course, you need your computer to help compute the movements of the robots. So these are the different possibilities of manipulators. The robot arm do not just come in one type of design. So many designs have been came out with over the years. And we have types like polar, cylindrical, Cartesian, and SCARA is one of the interesting ones that I will show you. And the photo you see here, it's called the Delta robot, and it works in a whole different way as well. So let's just take a look at it. So when you talk about manipulators, there's series and parallel manipulators. Series manipulators are your typical robot arms that you usually see in your TED Talks, in your documentaries. They are motors that have been mounted onto another motor and then mounted on another motor, so they can control the movement, something like that. Whereas parallel manipulators are motors that are mounted independently but joined at one point. So as you can see here, the figure on the right side, that's an example of a parallel manipulator. To help a little bit with the with how it looks like, so I'll be showing you a video on SCARA robot. So this is a SCARA robot that is a typical robot arm manipulator. So you can see that how fast it moves, and the reason for robot arms being deployed is it definitely helps you increase your productivity, helps you with the manufacturing processes, and the speed that it moves unparalleled to a human labor worker. Okay, so this is an example of a series or a serial manipulator when you have motors mounted onto one another. Okay. And now I'll show you parallel manipulators. Let's fast forward a little bit here. So you see that they have motors independently mounted, and then they join at one point. That's where the gripper is. That's where the end effector is at. They help you come with a wider range, and they can move a lot faster that way. So that's an example of a Delta robot. So a series and there's parallel manipulators. So those are the two kinds that we can classify industrial robots. Okay. Well, the newest technology right now and making the waves is collaborative robots. All right, so just to have a little bit of difference, industrial robots are the typical robots that works in cages. The reason why they work in cages is because they're huge, right? And when they're huge, the forces that they exert can be very, very fatal to humans. People have lost their lives, have lost their limbs. Whereas the new tech is collaborative robots, and they are made so that they can work alongside human beings. This to ensure that safety is there, and when there's a minor contact with a human being, the collaborative robots will stop. Not just that, is the ease of use of these robots, where they are smaller, they are lighter, and humans are able to move them and teach the robot how to move. So other than those robot arm technologies, we have mobile robots. Right? Mobile robots are robots that are able to move around the environment using wheels or legs. Okay? It helps you perform tasks such as your vacuuming or assisting human beings. So what you see here is a robot by Milver's Robotics, and they help with the logistic operations in a warehouse setting. You can see it's carrying a load, and then it's bringing it from one point to another. And all of this is done automated, right? Meaning it's already pre-programmed. It goes there, picks something up, and drops it off. And one of the latest news was shared with me yesterday by Brother Lukman was that a robot that looks like a dog has been seen in Ang Mo Kio Park. I don't have a photo of it here, but you can check it on the news. So that is also a mobile robot. Another mobile robot you can see here is an excerpt from Straits Times. is robots being used for the current COVID situation? Right? So these are mobile robots that have cleaning tools attached to them. You can see on the left side, which is called the XD bot, which is developed by NTU, or in NTU, it's called the Extreme Disinfection Robot, where they have a robot arm mounted on a mobile robot, and then it sprays disinfectant. Right? And then on the right side, you see Sunburst UV robot, which is what my company has been working on. Some of my colleagues have been working really, really hard on it. Is an AGV that has a UV light mounted on it. And then what the UV light does is that when it emits the light, it helps kill the viruses. So humans shouldn't be around it as well. So these are the types of innovation, and these are the types of scenarios where robots can be used for good. And with problems, humans will always come with a solution. All right. So those types of service robots that you see, robots that go out and do some sort of service. What are the other types of service robots that are out there? Entertainment robots, we have social robots, medical, and field robots. So field robots are something we've already covered earlier on. Other types of field robots, they don't have to be on land. They don't have to be walking with legs or wheels. Some of them can be in the form of UAVs, or better known as drones. UAV stands for Unmanned Aerial Vehicles. And what you've seen earlier on were AGVs. And we also have autonomous underwater vehicles or unmanned surface vessels. And these types of robots, you can imagine a boat with no human being and being remotely controlled or autonomously controlled. So those are the types of field robots which are also very, very interesting in this field. We also have medical robots. As you can see, the robot on the right side, it's called the Da Vinci. And this robot assists the doctors or the surgeons with some of the surgeries where they provide precision. Right? Robots, you can move without shaking. You don't have shaky hands. And they assist, they don't take over the surgeons, but they assist in helping increase their survival rate, etc. We have robots on the left side, which is a nurse robot that can help transport some of the patients from one place to another without having an actual nurse putting the nurse in jeopardy. For example, this current COVID situation. So this is one of the things that might be very, very familiar with most of you. Well, one of the first few famous ones are the Roomba. Is the kind of like robot vacuum robot that you just press on and then it just goes around your house, cleaning your house. So that's actually a type of robot. Reason why it is because it's making its own decision as it moves around. Using its sensors, it comes out with its own navigation and own decision-making processes, and then it goes around cleaning the house. Other types of domestic robots, this is a prototype, arms mounted on top to help you cook, right? Other than this may be a bit futuristic, but there are already burger flipping robots. And there's a hotel in Singapore, you can check it out, Yotel Singapore. That's where my fiance is working at. And over there, they have installed a universal robot, a robot arm that helps flip the omelets. And they actually cook omelets while the guests go into breakfast. So that's quite interesting as well. Okay, so that's a little bit of the current technologies that are out there. But I'm here now to share a little bit of the skills that are prevalent in the robotics industry. Right? Some of the very, very prevalent skills that are needed are mechanical design. So mechanical design comes back in the day in the form of mechanical drawings where you had to draw. But now with advancement of technology and CAD or computer-aided drawing, those are essential skills where you are needed. You can look into SolidWorks, and if you want to get started, you can go and check out Fusion 360, which is a free software online, which allows you to do some CAD drawings. So you have to be familiar with the mechanical elements such as shaft, coupling, bearings. Then you can create a viable product with that. And with mechanical design, you are free to design anything that you need on CAD. Second is mechanical simulation. at times where you feel that, okay, I've designed something, and if I make it, and you don't know whether it will break or not. So that's where you will have mechanical simulation. This is a simple type of mechanical simulation using finite element analysis, where you design something and then you put simulated stresses on it to see how well it will do under pressure, so that when you build something, you know that it won't break and waste your money. So that's where simulation can come in and help out with a lot of the prototype designs. Well, electrical and electronics is definitely one of the main things in robotics, where you go into prototyping. Soldering is also a skill you can easily pick up a soldering iron, try it out. Signal processing will take a bit of programming. Control theory is something that you might also go into deeper into robotics. Power electronics, just a simple, DC voltage pass into your small machines that make it work. They are also skills that you can help build on and relevant. And embedded systems or programming. I don't want to scare you, but embedded systems are just small little computers, right? And maybe most of you might be familiar with Arduinos. So they are also a form of embedded systems. They are a great way to start. Right? As you go into Arduino and making things work with Arduino, a simple LED turn on and off, you can start to upgrade yourself and try out a Raspberry Pi. And some of the languages that are very common if you want to get started are C, C++, and Python. But I really recommend Arduino. It's a great way to start. And more, as you go in a bit deeper, you can go into image processing, which is a very, very hot skill to have right now. And what it does is they are the sensors and then they are eyes of the robots. They can help make decisions for the robot. So some of the image processing software, you literally can drag and drop. Those are very high level functions. But as you want to create more customized concepts, or you want to create more customized solutions, then you will need to have conceptual understanding and mathematical understanding to create your own algorithms. But that will come later. So just want to share with you before we cover what you need to do is just to manage your fear of automation, that robots will not take over your jobs. In fact, they will help increase your productivity in your job. So the first mindset that I want to share with you is the inevitability of automation, is that automation will come in one way or another. It doesn't have to be in every single aspect of your life, but you've seen it from like the door opening by its own to the lift going down on its own, etc. But the inevitability of automation is something that you need to have so that you can build up skills that are relevant to it. Python or C may not be relevant now, but something else may be relevant. But with this mindset, it can help you detect what are the relevant skills in the future. The second skill is more for motivation. Like, I've already equipped myself with a certain set of skills, but then I can move forward. But that's not true. The skills that you need are complementary to what skills that you already have. Right? So let's say you have an admin job and then you want to go into robotics. Well, it doesn't mean that it ends there. Yeah, there's other technologies like RPA you can look into, which can help, and data analytics that can really help with some of those jobs. Right? The third mindset, this is the most important one I want to highlight, is that automation technologies are not hard. Right? If you want to start programming, right, you don't have to start with coding, hard coding few lines. What you can do is there's block programming where you can drag and drop certain lines of codes and make it work. So there's easier solutions as technology increases. EduTech is on the rise right now, educational technology, where it can help you learn faster, learn easier. So automation is not hard. And then the last mindset that I want to share with you is to exploit the increase in productivity. So as long as you can find ways to increase productivity in your processes, that's a mindset that's relevant in robotics. All right? So one more thing that I haven't included in, but I think it means a lot, is innovation. Innovation doesn't have to come in building something. Innovation can come with entrepreneurs. So with more entrepreneurs starting up, creating their own tech startups, I think they are helping increase the level of automation, or increase the level of technology currently. Yeah, with that, I end off my very short intro to robotics. I hope you guys have learned a lot in this really crash course. I feel like I'm talking very fast. But if you need anything, there's my QR code to my LinkedIn page. Let's get connected. And let's have a conversation if you want to know a little bit more about robotics. Thank you. Thank you for your time.
Let's get started.
Wow, very nice. Is that M-bot?
All right. Thanks a lot, Mr. Amir. I was so inspired by your talks on robots that I've decided to bring my son's Lego robot beside me to replace the next part of this segment. All right.
Yeah, you got to start them young.
So for the next part of this segment, we have Dr. Ahmad, who's going to be introducing to us additive manufacturing. Dr. Ahmad holds a first-class honors in aerospace engineering, and his Doctor of Philosophy is on the field of additive manufacturing. So Dr. Ahmad, take it away.
Okay. Can I start? Okay, good afternoon, everyone. My name is Ahmad. Today I'll be giving a very short and simple presentation on additive manufacturing. It's also known as, more commonly as 3D printing. Okay, before I formally start my presentation, I would like to play this short video clip. It will visually demonstrate how 3D printing works and also some of the applications that it has. Okay, I'll play it now.
3D printing technology is already changing the way we produce objects, from tools and toys to clothing and even body parts. 3D printing is part of a process known as additive manufacturing, where an object is created by adding material layer by layer. Additive manufacturing allows designers to create complex parts for machines, airplanes, and cars at a fraction of the cost and time of standard means like forging, molding, and sculpting. Now, smaller, consumer-friendly 3D printers are bringing additive manufacturing to homes and businesses. The first step in 3D printing is to create a blueprint of the object you want to print. You can use modeling software like Blender to create your own designs, or you can visit websites like Thingiverse or Shapeways to find objects other users have 3D modeled. Once you have a finished design, it's time to send it to the printer. Some printers, like the MakerBot Replicator 2, have renewable bioplastic spooled in the back of the device, almost like a string. When the printer receives the data, it pulls the material through a tube, melts it, and deposits it to the plate where it instantly cools. As you can see, the 3D object is created through layering, where the printer will add one layer of the object at a time until you have a fully formed structure. The most common material used in 3D printing is plastic, but the use of some other materials allow for the creation of some pretty amazing products beyond simple tools and toys. 3D printing food is becoming very popular, and additive manufacturing has allowed for the creation of some pretty intricate treats. In the medical world, doctors are testing biomaterials for regenerative medicine. By using a patient's cells, doctors could 3D print small body parts like ears and noses. Some surgeons have even tested 3D printed organs for transplants. Recently, giant 3D printers in China printed 10 houses in just one day and at a cost of less than $5,000 per house, proving just how cost and time-efficient 3D printing can be. For more on 3D printing, check out Mashable's latest coverage. And don't forget to watch the other videos in our Mashable Explained series.
Okay, as you have watched from the video, I think most of you have a rough idea of how additive manufacturing works. is more commonly known as 3D printing, but previously it was termed as rapid prototyping. I will touch on this later on. So as the name suggests, right, additive manufacturing. To manufacture is to make something. So essentially, additive manufacturing is a tool which is based on the additive method, which refers to a layer-by-layer process. So this layer-by-layer process is also seen in kuih lapis. This is why I've included this image of a kuih lapis. So how you would make a kuih lapis is to first set the bottom layer, and on top of this layer, you add another layer, and then another layer, and just repeat on this cycle until you get the full kuih. Also, a disclaimer, I'm not selling any kuih lapis to Mendaki, so just wanted to make it clear. Yeah, so other materials include metal, plastic, and also concrete. But this list is not exhaustive. Okay, this slide shows a typical AM process. You first start with 3D modeling. Let's say you have a design in mind or an optimized design of a part that you want to print. You would first structure this design in 3D modeling software such as AutoCAD or SolidWorks. And then you save this as an STL file. STL refers to stereolithography. You would then upload this STL file to a 3D printer and also input some of the printing parameters such as the type of material that you want, the layer thickness, etc. And then you click and then you press the play button. And from then on, you just wait for the 3D printer to do its job. And once the job is ready, you will remove the 3D part. And at this stage, for most cases, right, the 3D part needs to be post-processed, such as the removal of unwanted or excess material before it can be applied in whichever area that we want. Okay, these are some examples of 3D printing machines. What you see here is a 3D desktop 3D printer, the one at the top. I'm sure most of us have seen this desktop 3D printer at some point in our lives. It uses the FDM method, which refers to fuse deposition modeling, which makes use of a plastic filament. So what you get is a 3D printed plastic part. And in the future also, we might see 3D printers producing live organs such as a heart, for example. Yeah, and the range of 3D printing machines is from desktop to industrial. And the picture here at the bottom is an example of industrial 3D printers. It's by SLM Solutions. So these industrial 3D printers are very large in size, and also they cost a lot, more than $1 million upwards. Yeah, but in order to operate this kind of industrial machines, you will need special license or certifications. Yeah. Okay, I'll just touch on a brief history of additive manufacturing. So it began in the 1980s, where it was termed rapid prototyping. So during the 1980s, they mainly used 3D printers for concept modeling. Let's say you're a designer or engineer, and you want to make a part, but you have a rough idea of the design, and you would realize or fabricate this design using a 3D printer, and this design would then go through some more iterations before the final part is ready. So as time passed and technology advanced, more and more companies or industries saw the potential of additive manufacturing as a future of a manufacturing method. Yeah. So for example, GE, General Electric, they have invested a lot of time and resources into AM. For example, here it shows that they spent $22 billion into making fuel nozzles. So the 3D printed fuel nozzles are already implemented in their turbine engines. Okay, however, these 3D printed parts have to reach a certain standard before they can be accepted in the industries. And also right now, a lot of research and development are being made before the parts can be fully accepted by the industries. And this will take more time. Okay, additive manufacturing now. Okay, due to the current situation of COVID-19, right? So healthcare professionals require face screens and also ventilators for COVID-19 patients. So 3D printing companies are now printing this part, such as the orange part of the face screen here. So it's just a plastic part which is used to hold the plastic part of the face screen. And also these are ventilators. There's a high demand for such medical devices. That's why this 3D printing is actually an advantage, because you can just make make these parts anywhere as long as you have a 3D printer. And also the files are open source, so anyone can have access to these files. Okay, like I mentioned earlier, 3D printing is only used in the healthcare and medical fields. Okay, another example here is that if you have a hole in your skull, yeah, you can just 3D print a titanium alloy implant, for example, and just stick it to your skull, for example. And also the bird broke its beak, so yeah, you can just 3D print a beak. Okay, moving on from medical and healthcare, in the construction industries, like from the video that I watched earlier on, concrete can be extruded from a moving nozzle, and then you do this layer by layer, and what you end up with is a 3D printed house or a 3D printed toilet, for example, if you require a 3D printed toilet. Yeah, also in the jewelry and fashion industries, right? Typically, it would be, I would say, impossible to manufacture these accessories that you see here using traditional non-conventional methods. So what the designers leverage on is by using 3D printing to make their designs a reality. Yeah. So yeah. So in the food industry, for the video also, we have shown that there are chocolate 3D printers if you want to print chocolate of any shape, size, or form. Yeah, so it's possible to do using chocolate 3D printers. And also, I included this picture of old folks because research has actually been done to show that 3D printed food is more appealing to the older generation. Yeah, and also they might include some medicine in the 3D printed food. Yeah, for all we know. Types of additive manufacturing. This slide shows the different types of AM processes. I would say that each process caters to different materials. So for example, powder bed fusion technique, it usually caters to printing metal parts with lasers or fiber lasers as the processing tool. Another example would be material extrusion. It uses plastic. So typically you would print plastic parts. Okay, this slide is just a schematic to show how the different AM processes work. Yeah, so for SLM, it uses the laser as a processing tool, and the working material is powder. But the underlying fundamental principle is still the same. It's a layer by layer process. Yeah, it's common throughout all the processes here. Okay, now we come to the benefits of additive manufacturing. I would say the most benefit of additive manufacturing is the optimized design. So in this picture here, the colorful one, it shows a hinge bracket. So let's say you have a hinge bracket, and you use additive manufacturing not to manufacture the exact same design, but instead you leverage on the optimized design. So you come up with a skeletal design which uses less material and translates to less cost. So you use less material, and this results in cost savings. Okay, so you subject this skeletal design using FEA or finite element analysis, as mentioned by Amir just now about the mechanical arm. Yeah, so once you get this design right, to show that it can withstand the load during application, and then you 3D print this design, you make it a reality. Okay, moving on to the next benefit is reverse engineering. Let's say you have a existing part which is made up of a different material, but you want to have the same part of a different material. So what you would do is to 3D scan the existing part, and then you get the STL file, and then you print using a different material. So that's essentially another benefit of additive manufacturing. Okay, moving on to the next advantage. So what you see here is a small Olaf toy, right? So instead of 3D printing the Olaf toy individually, what you will do is to print the gray mold and then use casting to manufacture this Olaf toy. So actually this would save a lot of time and cost if you want to print a lot of parts at one time. Yeah, so it's more time saving and cost savings if you were to print just the mold instead of the parts individually. Okay, moving on to the next benefit is a complex part manufacturing. So what you see here is Adidas sneaker. So the sole of the sneaker is actually in a lattice structure. So this lattice structure is impossible to be made using traditional conventional methods. So that's why Adidas 3D printed this sneaker and market it as a very special and unique sneaker. And the picture beside is a turbine blade 3D printed by Siemens. As mentioned by Dr. Airil just now, these turbine blades, they have cooling holes within them. And to manufacture or to repair this turbine blades is actually very troublesome using traditional methods. So additive manufacturing helps in this sense. Okay, traditional versus additive manufacturing. This is just to show that traditional manufacturing is usually subtractive manufacturing. And you start off with a bulk material, and what you end up with is a lot of waste. However, this is in contrast to additive manufacturing, where you start off with the amount of material that you would require, and then you get the same part that you get, but minimal waste. Also, this waste can be recycled for the next build job. Okay, some cons of additive manufacturing. Okay, firstly, what you see here is a 3D printed part using the powder bed fusion process. It has metal support structures. So these metal support structures are necessary during the build process because it helps to reduce the thermal gradient and also helps to support overhanging structures. However, when you are done with the build job, you require to remove these metal support structures. This mechanical intervention can actually potentially damage the part because you have unwanted stress and compression in some parts of the build job. Yeah. Also, high material costs. Let's say, for example, a metal powder like say titanium. From what I remember, 5 kg of titanium alloy costs around $600 to $700. So it's very costly to manufacture these parts. Lastly, I would say another con is long testing and certification times. So what you see here is a 3D printed part that looks good. It probably works, but you would need to subject that part to rigorous testing so that it can meet a certain industry standard before it can actually be accepted by the industry and deemed safe or ready to be used. Yeah. Okay, research in additive manufacturing. There are some areas of research such as new materials, ceramics is up and coming. Multiple materials for one part, 3D bioprinting, 3D printing of electronics, for example, and also simulation studies to optimize the additive manufacturing process, and also to predict future failures of the process. And lastly, I would like to touch on design in AM is also a critical component in additive manufacturing, because this is what we want to leverage on, the optimized design. I'll just play this short video clip of research done in NTU. It's 3D printing of a toilet. Yeah. Okay, so what you saw earlier is a 3D printing of a toilet using a 6-axis robot. So there are overlaps between 3D printing and also robotics or automation. So I think that's quite interesting. Okay, 3D printing in Singapore. If you are interested in 3D printing, you can enroll yourself in courses at some polytechnics, I believe Singapore Poly. You can use your work skills future credits. Yeah. Also some academic institutions which have heavily invested in 3D printing, such as NTU. They have SC3DP, also NUS, and also some other companies which use additive manufacturing as to manufacture their parts, also to maybe to repair existing components. Yeah. Okay, just to summarize, with 3D printing, you can make almost anything, anywhere, and anytime, as long as you have a 3D printer that you can access. Okay, so the advantage is that you can print complex and customized parts. So this is where the design in AM is critical. However, there are high barriers to entry, such as long testing times and also high costs. Yeah. So with that, I would like to end off my presentation.
All right. Thank you, Dr. Ahmad, for sharing the exciting world of 3D printing, where you can almost manufacture anything that you can think about. I remember when I was in school, we were still doing lathe and milling machine, slogging at the machine, turning the handles, and then now everything you can just 3D print it, including metal components. So fantastic! Thanks a lot, Dr. Ahmad, for sharing with us on additive manufacturing. So with that, I'd like to go on to the Q&A questions. Some of you guys have already asked some questions, and you have already answered on the poll. I'll kick it off with a question for Amir. So Amir, how do I gain skills to do robotics, and how can one get started with robotics in Singapore?
Good question. Thank you so much, Airil. Good question. I myself didn't start with a conventional way to start in robotics. But if there were a way for me to make it easier for someone to get started in robotics, it would definitely be starting it with an Arduino. So an Arduino is a small set, a small computer that you can just plug and play, and then literally download the software and run some codes in. And Arduino is one of the greatest way because you're already starting it in secondary schools, where you can just download a code somewhere online and just plug it in, plug a simple LED to turn it on and off, etc. So the reason why I recommend starting with Arduino is that once you see that you've coded and it came out from your own code and run it, and then you see the light turn on and off by your you made it happen, you get a sense of motivation to try something a bit more daring, try something even more. Next, you're going to try turning a motor. Like, okay, I can turn a motor now. Let's create a robot arm, for example. Okay, I can do that. Let's do a drone now. So that's how conventionally people get started with Arduino. So of course, when you're young, you start with the Lego Mindstorms, but they can cost quite a lot. But Arduinos are pretty cheap. You can get them below $50, start playing around. Once you really get the hang of it, oh, by the way, Arduino is coded in a variation of C language. So once you get a hang of Arduino, it's easy for you to transition into C. And once you get the hang of C, Python will be a lot easy for you to get your hands on and try coding. And if you really want to bring it to the next level, once you've mastered or have a certain level of competence in Arduinos, you can go into Raspberry Pis, which are single board computers. So most of your computers right now are like quad core, octo core, core i7, something like that. But Raspberry Pis are single, they're just one chip. So their computation power is not so high. It's not so strong, but it will help you with the next level of robotics that you want to increase on, and then you will go on to learn more OSs like Linux, etc. But if you really want to start, I recommend Arduino, and then follow up with a Raspberry Pi. And there are so much resources online. The internet is your oyster.
All right. All right. Thank you, Amir, for sharing with us using Arduino, and I really thank you for sharing with us something that's cheap as a father of 3 kids, and I think Dr. Airil also can attest to that as a father of 4 daughters. A cheap option is good. So thanks for sharing on that. So the next question goes to Dr. Ahmad. Yeah. The question is, I would like to work in the 3D printing field, and what must I equip myself with? So Dr. Ahmad.
Okay, so the question is, like to work in 3D printing field, is it? Okay.
Yeah.
Okay, so actually 3D printing is just a tool. Okay, so I would first say is to identify your area of interest. Let's say your area of interest is in electronics. So they have 3D printing of electronics that's up and coming. But if you want to get into the 3D printing field in general, right? There are courses offered by polytechnics, like I mentioned earlier. So you can attend this kind of courses where they will teach you the fundamentals of 3D printing, different types of 3D printing more in depth. They are conducted by 3D printing specialists. From then on, you get a certificate. I guess you get a certificate. Other than that, let's say, from what I know, some companies are investing in 3D printing as a future of a manufacturing method. Let's say you get into a company and they have a 3D printing department. Yeah, so maybe you can express interest to join this 3D printing department if you're really keen. Yeah. Other than that, if you want to know more and you want to start off as a hobby, you can always get the desktop 3D printer. Yeah.
All right. Very good, Dr. Ahmad. Thanks a lot. Thanks for sharing that. Third question goes to Airil. How can we become competent gas turbine engineers in terms of knowledge and technical abilities?
Okay, so I'm assuming that the person that asked this question have a job as an engineer already. Okay, so for the students that wants to go into engineering, my advice to you is that always remember the concepts that you learn in school, be it in secondary school or tertiary institution, because as an engineer, your foundations needs to be very strong. Your concepts need to be very strong as well. So for example, if you learn about thermodynamics, fluid mechanics, so most of the time when you carry out your exam, you basically control alternate delete, you delete everything from your brain. But my advice to you is that you retain that knowledge, because you will need to use that knowledge if you're going to be good engineers, right? So your fundamentals need to be strong. And then I'm hoping that the company that you are in offer training courses or programs that will basically increase your level of competency along the years. So typically, as a fresh engineer, you'll probably take about 2 to 3 years to be competent enough to do your job without much supervision, right? So for me, for my experience in Rolls-Royce, I'm posted a lot overseas in UK. So I get the opportunity to sit down beside a specialist that has been in the company for a very, very long time. So you get to ask questions, you learn on the job. So you get assignments, projects, investigations. So you ask questions, you keep asking questions. That's what a good engineer is. You keep thinking, especially critical thinking, asking the right questions, right? And then, of course, you need to have the necessary exposure and breadth of projects and investigations as well. And then, as you go along the years, you increase the depth of your work as well. So you increase that level of complexity in your task, and also the impact of your work to the business. So I think that's how you systematically, increase your level of competency.
All right, thank you. So maybe we have time for just about 2 more questions at most. I'll punt this over to, this is a specific question for Dr. Ahmad. Yeah, Dr. Ahmad, I like to work as the one 3D modeling the object in the industry rather than doing the print itself, I believe. What is the skills that I must have to do that?
Okay, firstly, I would say you need 3D modeling skills. So if you know how to use 3D modeling software such as SolidWorks and AutoCAD, so that'll be a good start. Secondly, let's say, like I showed earlier on, right? So this softwares can be used to design parts, but you need to know how to design the part. So let's say you want to design something that is a load bearing. So you need the mechanical engineering knowledge about tension, compression, and all this to fully optimize the design. And then from that design, you will do finite element analysis. So this is a simulation software. A simulation software such as what is it? Abacus. Yeah, I think Abacus is a simulation software where you can test out your design. So to see whether or not it can replace the existing part. Yeah. So you need 3D modeling software and also finite element FEA knowledge. Yeah. Before I think that's a critical. You want to be a AM designer. Yeah.
All right. Fantastic. Thanks for sharing, Dr. Ahmad. I remember those days when I was still doing 3D design, switching from SolidWorks to FEA and seeing the red, amber, blue, and
the rainbow.
The rainbow, and seeing us being able to lighten the part while still managing the same forces going through it. I think that's quite exciting.
Yeah.
Yep. Okay, so I think we have one last question. Time for one last question. So the last question is, where was this? How can engineers help to fight global warming? I'll answer it first, and the rest of the panelists can chime in. So how can engineers help to fight global warming? So I think there's a couple of ways in this space. So as an engineer, first and foremost, you can work in that particular field itself of environmental engineering. So this could be dealing with alternative forms of propulsion or alternative forms of energy creation. Like we were talking last week about electric propulsion. So as an engineer, you could be working in those space. You could be working on photovoltaic cells, or you could be working on turbines, whether it's wind turbine or sea turbines. That's definitely an alternative or a cleaner source of fuel compared to carbon fuels. In fact, next week, when we have Mr. Aziz Merchant, who is the Executive Director for Keppel Marine Technologies, I believe we'll touch a bit more on it as part of Industry 4.0 also, what to look forward for in the future. And on top of that, as engineers in our current day job, we may not be working in radical global warming tasks or jobs at the moment, but everything you do, you can always take into account the environmental consequences. So for example, if you are designing a part, you also design it with the manufacturing ability, or rather the manufacturing process in mind, to reduce the amount of wastage, to use less material. That definitely contributes everything to that. Or if you design a process line or process clean line, how do you minimize waste or discharge going into a land, or how do you contain those discharge? So these are the things that you can definitely be a part of, and every little step matters, or every little action matters. So I don't know, the panelists, do you want to add any more to that?
Yeah, sure. Maybe I can go. I think every single engineer in whatever department you're at, I think the ability for engineers to innovate new processes that can help reduce the carbon footprint. I think overall collectively, all of us can help with global warming. For example, simple initiatives like your department just recycling the bottles or something, or even creating some sort of processes that can help reduce plastic waste or something like that. I mean, we're engineers, we'll think of something to bring down the carbon footprint. And I think regardless of whatever industry you're in, everyone has a part to play.
How about Dr. Airil, when it comes to engineers fighting global warming with regards to gas turbine?
I got a few points. I think if you were to look at what Rolls-Royce or other major aerospace companies are doing, so they are, I would say, investing a lot in the geared turbo fan engines, right? So if you have the geared turbo fan engines, you can actually turn the fan at a slower speed, and in that way you actually burn less fuel, and then you have a lower carbon emissions as well, and improving efficiency. And then I think, as what you mentioned, we're also looking at hybrid electric engines. So in the future, you're gonna have like Tesla, flying out there. So this will also help in reducing the carbon footprint. And I think I'll just share a short story. After I graduated, it was 2009. We were really into clean energy at that point in time. And I think if I can inspire people in the future to look at renewable source of energy, that would be really great. I had the passion to do wind turbines as well, and you know, students can actually look at creating small wind turbines, in fact, that you can place on top of HDB buildings, for example. So these kind of ideas are always welcome, right? So I think, as what Amir mentioned, engineers, you need to be innovative. Nothing, you cannot restrict yourself into being normal or thinking normally. Yeah.
All right, fantastic. So, Dr. Aaron, that actually leads me, as you talk about HDB and the top of HDB, that leads me to Dr. Ahmad to bring home on how can engineers work towards fighting global warming. And maybe you can share with us the work that you're doing at the moment.
Oh, okay. So I start with respect to additive manufacturing. Right? So essentially, if you place 3D printers like everywhere in the world, then it just eliminate the need to like import and export parts. So this would, I guess, reduce some carbon footprint lah. Yeah, because in transportation and all this. Well, okay. With regards to my current work, I'm working as a research engineer at Republic Polytechnic. But right now I like to identify myself as a urban farmer. So the idea is to put these urban farming systems on the rooftops of HDB buildings or multi-story car parks. So this is in line with Singapore's 30 by 30 vision, which is to produce local vegetables and food supply up to 30% by 2030. Yeah, so this type of innovations and IoT applications is required to make this a possibility in the future. Yeah, so different type of engineering ideas and are always welcome. Yeah.
All right, thanks for sharing. So I think all the panelists have shared how engineers can, or the many ways in which engineers can help to fight global warming. And this actually leads us to the next week's session for Industry 4.0, where managing global warming, talking about the new technologies, robotics, AI, talking about additive manufacturing, we'll pull it all together into what is the changing landscape for the future. So before we end this session, maybe if we would like to invite everyone to take a picture just to commemorate this session. If everyone could come on and then turn on your videos for us to share this interesting moment.
All right, so in a few moments, you will be upgraded to a panelist role. Being a panelist will enable you to switch on your webcam. We highly encourage you to take part in this memorable activity.
Don't be shy. Hi, everybody. Turn your webcam, say hi. All right, we'll give you guys a minute or two just to turn on the webcam, and Liana will do the honors, right, Liana?
All right, anyone else would like to join us?
Anyone else like to join us?
And so I'll take both a print screen as well as a normal photo for your phone camera. So on the count of 3, let's do this together. 1, 2, 3. One more. 1, 2, 3. All right.
All right, fantastic. And so thanks a lot, everybody. Thanks a lot, Liana. With that being said, I really hope you enjoyed this session. Thank you to the panelists for sharing their experience in this space. Do remember for next week, we have Industry 4.0 and the changing landscape. Sorry, sorry. In that, Mr. Aziz mentioned, who is also on this session just now, and myself, sorry, who will be sharing with you a bit more about Industry 4.0 and what we can do in that space. So thank you guys for joining, and I'll see you next week. Adios.
Pleasure is mine. Thank you for
Alright,
having
so
us.
I would just like to add on a little bit. So at the end of the session, I would like to thank everyone for being part of this. So do continue to follow Mendaki's website, Facebook, or Instagram to be on the loops of the latest events and tips. After this session, there will be a feedback form. Do participate in that, as your views will help us to understand and curate future sessions. So we meet again next week for the last session of this series to know more about Industry 4.0. Have a blessed weekend, everyone. Stay safe.